Hello everyone. This is the video lecture for the topic Error Backpropagation for 5th unit of Artificial Intelligence and Machine Learning. Backpropagation is a training method used for a multi-layer neural network. It is also called the generalized delta rule. It is a gradient descent method which minimizes the total squared error of the output computed by the network. The backpropagation algorithm looks for the minimum value of the error function in weight space using the technique called delta rule or gradient descent. The weights that minimize the error function is then considered to be a solution to the learning problem. Backpropagation is a systematic method for training multiple layer ANN. It is a generalization of window H of error correction rule. 80% of ANN applications uses backpropagation. Consider a simple neuron. A neuron has a summing junction and activation function. Any nonlinear function which is differentiable everywhere and increases everywhere with sum can be used as activation function. So this image shows the backpropagation network. The usual operation will be happening in the neural network. Summing junction will sum up all the input values and multiplied with the weight, and finally the total sum will be added to the bias. This summing function will add the total sum to the bias, and this final sum value will be applied to the activation function. So here the backpropagation happens based upon the concept of minimizing the error. This backpropagation will be happening in the activation function. Example of logistic function or tangent function, hyperbolic tangent activation function. This activation function makes the multi-layer network to have greater representational power than single layer network only when non-linearity is introduced. Need of hidden layers. A network with only two layers can only represent the input with whatever representation already exists in the input data. If the data is discontinuous or non-linearly separable, the innate representation is inconsistent and the mapping cannot be learned using two layers. Therefore, hidden layers are used between input and output layers. Weights connects unit in one layer only to those in the next hidden layer. The output of the unit is scaled by the value of the connected weight, and it is fed forward to provide a portion of activation for the units in the next higher layer. Backpropagation can be applied to an artificial neural network with any number of hidden layers. The training objective is to adjust the weights so that the application of a set of inputs produces the desired outputs. Training procedure. The network is usually trained with a large number of input-output pairs. Generate weights randomly to small random numbers to ensure that the network is not saturated by large values of weights. Choose a training pair from the training set. Apply the input vector to the network input. Calculate the network output. Calculate the error, the difference between the network output and the desired output. Adjust the weights of the network in a way that minimizes the error. Repeat the steps 2 to 6 for each pair of input-output in the training set until the error for the entire system is acceptably low. The backpropagation involves two passes, forward pass and backward pass. In the forward pass, the calculation of the output is carried out layer by layer in the forward direction. In the backward pass, the calculated error signals propagate backward direction through the network where they are used to adjust the weights. In the reverse pass, the weights of the output neuron layer are adjusted first, since the target value of each output neuron is available to gauge the adjustment of the associated weights using the delta rule. Next, we adjust the weights of the middle layer. As the middle layer neurons have no target values, it makes the problem complex. So the selection of number of hidden units are important. The number of hidden units depends upon the number of input units. Factors influencing the backpropagation training. First one is bias. Network with biases can represent relationship between the input and outputs more easily than networks without biases. Momentum. The use of momentum enhances the stability of the training process. It is used to keep the training process going in same general direction, analogous to the way that momentum of a moving object behaves. So that's all about the topic. Thank you.